Yeah.
Don't top the other one. Once the first one's been handed, one thing has been handed in, a stack has been created. Any questions? Ryan?
On the solutions for work test number.
Sorry. Get. Okay, go again.
Okay, so on question 16.
16,
Yeah, 16.
a test charge, okay.
Yeah. So I understood up until 14.4, and became 10. Like, for like the answer. Like, I got a little confused.
All right, so you, wait, let me do a quick scan here. Separated magnitude of force on the test charge and direction of the force. Okay.
I got confused again. Yeah, like how 14.4.
Oh, yeah. All right, so that particular thing is if they're taking significant figures into account, because all of the answers have only one significant figure. So therefore, they rounded to one significant figure there. I understand why they did that, but it really seems unnecessary. Was that answer to the question?
Yes.
Okay. Any other questions? Erica, you inhaled like you were about to ask a question. Problem 26.
Yes.
2-point charges, Q1 and Q2.
Yes.
3 meters apart, total charge 20 microcoulombs. And their total charge, all right, so if you add them together, force of repulsion is 0.75, what about these charges? Okay. So you had a question about why the solution set it up the way it did?
Yeah, well, I guess I put it in the calculator formula, but it's just not matching with that. I don't know, I just wanted to see it done.
Okay. All right, so problem 26. We have, they're 3 meters apart. So Q1, Q2, 3 meters apart. And their total charge is 20 microcoulombs. Just to simplify some of the notation here, I'm just gonna make that X and that Y, just so I don't have to worry about subscripts. So I know that the sum, X plus Y, is equal to a total of 20 microcoulombs?
Yes.
Yeah. So 20 microcoulombs. The other bit is that the magnitude of the charge, it's repulsive, so I know they have to be the same sign. And because the total is positive, they're both positive charges. And the force is 0.075 newtons. So I know that K x y over r squared is equal to, where r is equal to 3, equals 0.075 newtons. So I have two equations, two unknowns. K is a constant, r we know is given, and so it's a matter of solving. So it doesn't, in essence, I can solve for x and plug into here, or solve for one of these variables, plug into here, or solve for one of these variables and plug into here. Either way. I think they solved for one of these and plugged into here. Actually, what I'm gonna do is I'm gonna get this stuff over to the other side. So I'm going to divide by k, multiply times r squared. So I have xy equals 0.075 times 9 divided by 9 times 10 to the ninth, which is 7.5 times 10 to the negative 11th. If I did that right. 9's cancel out. Yeah. So I know the product is 7.5 times 10 to the negative 11th, and the sum is 20, or 2 times 10 to the 5th coulombs. So now it's a matter of solve for one, solve for a variable, plug it into the other equation. If you're gonna end up with a quadratic either way. You wanna keep going?
Yeah, you keep going.
Okay. So I'm gonna take the first one, solve for x, yx, why not? Is 2e5, shorthand notation for 2 times 10 to the 5th, minus y. Plug that into here, so I have 2e5 minus y times y equals 7.5 e negative 11. Distribute 2e5y minus y squared equals 7.5 e negative 11. I have a polynomial, second order polynomial. Solve it by setting it equal to, get everything on one side, quadratic formula. Get everything over on the right. Let's equal sign there. And now quadratic formula. And if you need quadratic formula, it's either going to be at the top of the page on a quiz, top of the first page on a test, or just ask. So y equals 2 times 10 to the 5th plus or minus the square root of 2 times 10 to the 5th squared minus 4. Oh, God. You know, it helps if you don't make an error. Negative 5. Negative 5, negative 5. Negative 5, negative 5. Negative 5, negative 5. Times 4 times A, which is 1, times C, 7.5 times 10 to the negative 11th, all over 2 times 1. So 2 times 10 to the 5th, or negative 5th, plus or minus the square root of 4 times 10 to the negative 10th, minus, no, those are both positive. So 4 times 7.5 is 15, so 3, so this is minus 3 times 10 to the negative 10th. 2. So I have 2 times 10 to the negative 5th, plus or minus the square root of 1 times 10 to the negative 10th, which is 1 times 10 to the negative 5th, divided by 2. So I end up with 1.5 times 10 to the negative 5th, and if I can do math here, or 0.5 times 10 to the negative 5th. And it turns out those are both solutions, that's x and y. Officially that's x, you would plug into there to find y, but you'll find that that will produce that as y and that will produce that as y. And you can double check it. If you add them together, you get 2 times 10 to the negative fifth, and if you multiply them, you'll get 7.5 times 10 to the negative 11. Is that sufficient, or?
Yes, yes.
Okay.
And then for part B, it's the same thing, just, finding the,
They attract, so you know there'll be opposite signs, magnitudes and charges, so the difference would be, mathematically, the difference is that. Okay. Other questions? Ryan?
35.
Show the electric field lines near 2 charges, Q1 and Q2. What is the ratio of their magnitudes? Let's see, figure 18.47. Okay. Oh, sorry, not show. That figure shows the electric field lines near the 2 charges. Well, the electric field lines are going out of one and towards the other. So therefore, the red dot is, does it actually say plus on it? I can't quite tell if that's a plus or just a border. Anyway, the one on the left is positive, the one on the right has to be negative. Because electric field lines go away from positive towards negative. The electric field, one way of expressing the strength of an electric field is by number of lines. So if you look at the number of lines, part of me wants to go with, it's just an incomplete drawing. The ratio of their magnitudes. If there's nothing else, that's going to go there. I have 2 answers here, now that I'm looking at it right now. If you count up the number of electric field lines going out of positive and going towards negative, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So, unless I miscounted, like a ratio of 23 to 12. Negative. Yeah. Based on the number of electric field lines that are going away and going towards. Because I see a little note I have written here of 23 over 12. They would be opposite charges, so we might be printed in there, I can't quite tell. If you are, was the question about that or the question about part B?
I mean, the question, like.
The whole thing?
Yeah.
So, the ways of expressing the strength of an electric field, since it's a vector, you could just make longer lines for a stronger electric field and shorter lines for a weaker one. Or if you want to do a continuous line like they have here, it's based upon the concentration of the lines. That I have far more lines going away from the positive charge than I do going into the negative charge. And so it's a stronger electric field coming from the positive charge just because of the higher density of lines and therefore a larger charge. If I'm far enough away, then at some point, as I get farther and farther away, I really can't differentiate between the two. It's like it's one object at some point. So if I'm a long distance away, since if the positive charge, if it's a ratio of 23 to 12, or negative, overall it's going to be positively charged if the positive charge is greater. And so what it would look like would be, I've got a positive charge there, electric field lines are basically going away from it. Is that sufficient, or do you have follow-up?
I think I understand it, yeah.
Okay. Other questions? Yes.
So I have a few questions. They're not about the math, they're more about the direction.
Okay.
So like number 32.
Find the direction and magnitude of an electric field that exerts that force westward on an electron. That problem? Okay.
Why is the answer east? Can you like?
Okay. Louder, please.
Why is the answer east?
One more time.
Why is the answer east?
Magnitude of an electric field that exerts. Remember that electrons are forced opposite the direction of the electric field. So if the electric field is westward, lost it again, there we go. Sorry, if the force is westward on an electron, that means the electric field must be going the opposite way.
Okay. And I also had a question about
About what? You faded there in my hearing.
trying to find the question.
Okay. While she's looking it up, other questions? Right?
Like 60 overall, 60 like overall.
60?
Yeah.
The 5 gram charge of the insulating ball?
Yes.
All right. How much do you recall about force diagrams? So we're given the angle, we're given the mass, 30 centimeter long string, given the charge on the ball, find the strength of the field. That's 8 degrees. I don't know why I think I'll remember it, but 5 grams, 30 centimeters. So that has a mass of 1.5 grams. That has a length of 30 centimeters and angle there. All right. What are the forces acting on the ball?
Gravity going down.
Say that again?
Like, G, right, down,
G.
like gravity, no.
What's the name of the force?
Acceleration due to gravity.
Say it again?
Well, yeah, acceleration due to gravity.
That's not the force. Yes, say it.
Force of gravity.
Okay.
Gravitational.
Otherwise known as, pardon?
Gravitational force.
That works too, otherwise known as?
Wait.
There we go.
Oh.
All right, so I have weight acting down. What other forces are acting on it?
Tension.
Okay, and going up at that 8-degree angle there. And the new force, because we're in physics 152, not 151.
Force.
There we go, yeah. There's gotta be an electric force acting off to the right. So I guess. F is now spelled with an E. What this is a reference to is a checklist for forces: electric force, friction, tension, other normal force, and gravitational force. All right, so we've got that, and it is in equilibrium, I am assuming. It just says it hangs, uniform electric field. The electric field is going to the right. So first off, is the charge going to be positive or negative?